Okay, we are live now. Hi everyone, कैसे हैं आप सब? So sorry guys for the delay. There is some technical issue. So we'll be starting in a moment. Just tell everybody to join this workshop because this is gonna be so much fun and innovative. Okay, let's just wait few more minutes. Okay, till then let's have some chit chat. Hi, hello, Sisadra. I hope I pronounced your name correctly. Okay, okay. So, hi guys, welcome to another workshop with Geeks for Geeks, Solving for India Hackathon series. I am Mishika and your host for today. So, okay, Geeks for Geeks, in collaboration with Google Cloud and AMD, is proud to present Solving for India, a Pan-India Hackathon. Don't miss this exciting opportunity to showcase your skills and work on innovative projects that can make a real difference. And today with us, we have Mr. Manish, and today's topic going to be innovative health tech solution with GCP. Okay, let's welcome Manish. Hi Manish, how are
Hey,
you?
hi Mishika. All well, thank
Yeah,
you.
yeah. So
So,
Manish, just give a quick introduction of yourself to our audience, and then everything is over to you.
okay, so first of all, a very warm good evening to everyone in the audience, and my apologies. I'm on the road. You can trust me. I think Gurgaon traffic is something that is very unpredictable, even with Google Maps. I hope there's someone in the team today who's going to come up with a better solution, maybe with drones or anything. But yeah, till the time I'll manage running such sessions from my car sometimes. But yeah, a quick intro about myself. I'm Manish Sharma. I lead the healthcare and life sciences practice for Google Cloud in India as an industry principal, and my role is largely to look at how do we solve tech for healthcare and life sciences when it comes to from an Indian or from Bharat's perspective, as we say, right? And what are the global solutions that some of the solutions that Google Cloud specifically we are building worldwide, which can be taken to a lot of the clients. And at the end of the day, I think the larger remit as Google, what we believe in is something that healthcare needs to be accessible to all and affordable to all. I think that's the core principle. We work on that. And yeah, looking forward to have this team work on a lot of those exciting solutions in the future, which can help a lot of the people in the healthcare and the life sciences fraternity. Mishika, can I just go start with my presentation?
Yeah, sure. Let me add it. So yeah,
Okay.
over to you.
Okay. So now, folks, what we are gonna do in next 45 minutes or so is that I'm just going to give you a brief about what Google Cloud is actually doing in within the remit of healthcare and life sciences, right? And what I understand is there's a good technical community, and what I've also been given an understanding that a lot of you folks have gone through a lot of the fundamentals of the Google Cloud, right? So I'll not get into the fundamentals of the Google Cloud per se, but I would touch upon more specifically what we are trying to do in the healthcare and life sciences. And what I would also want to encourage each one of you is to look at a lot of these solutions which can solve for healthcare problems in the country, right? So, first of all, it's understanding the industry, right? It's if you look at, I'm not sure if a lot of people, I think you folks have been working on some of the solutions towards the healthcare and life sciences side of it, but there's still a lot of uh, I would say an ambiguity the way industry perceives healthcare and life sciences, right? The core tenet or the principle that needs to be understood is whether you're talking about healthcare and life sciences. Number one, they are not interchangeable terms. Second, which is very important thing, is more about while the core principle which binds the healthcare and life sciences with a common conduit is the doctor patient at the core of this ecosystem. And but the delivery mechanism for a healthcare versus a life sciences is totally different. And some of you who are actually working on these solutions would know it very well. But if for the uninitiated, I thought that this differentiation has to be called out upfront, right? Because that's how your solutions are going to be differ a lot, whether you build on Google Cloud or any other platform. But at the end of the day, the end users from the perspective is very different. That's number one. Second thing that's very important for us to understand is that, typically when we talk about the world healthcare, it's very easy to comprehend that we are building for the patients or the side of the customers who are the consumers of the healthcare. What we often mistake, in terms of looking at an important stakeholder who is the clinician or the doctor, who is actually the care delivery mechanism providing that experience to the patient. So this is very important. When we are building the solutions, it has to be all encompassing, with the doctor and patient at the heart of it, and then we are building that entire narrative around it, right? Other thing is, from a compliance perspective, it's very important to understand there are certain key compliances which are there, which governs healthcare. Now, a lot of you may be aware on some of those compliances, but it's good to understand that what makes a lot of sense from a regulatory perspective in healthcare. What differs healthcare from any other industry or a segment is there are a lot of regulatory requirements that we have to adhere to for all the right reasons, because it's a lot of the confidential patient data which has been dealt with here, right? So that's very important. So when we are doing those innovations, it's also very important to understand that we are complying with the data regulations of the data on which we are actually building our solutions, right? Second thing is, if you go do a kind of a typical Google search, right? This is what you're gonna get in terms of, like I said, there's still a lot of ambiguity in terms of how it's defined, right? The entire healthcare and life sciences landscape, right? I don't know what Bard or Chat GPT are gonna talk about it, but this is something that is still. But the differentiation, what I just gave it to you, I think if you understand that, I think that's more than enough in terms of running that. Now let's understand what constitutes healthcare and life sciences, right? Now, when you look at, if I were to start from the bottom side of it, right? So typically, this is what a lot of us are very comfortable in knowing that, right? That the healthcare, the delivery mechanism, the primary care, mom and pop shop, a doctor or a hospital chain that we deal with, right? But then there is much more to it in terms of the delivery mechanisms towards healthcare, right? Then you talk about, if you are working, let's say, for a solution targeting a US market, you would have heard a term called payer, which is a word used very colloquially to define the health insurance side of it, right? And in India we call it health insurance as a health insurance, right? So but then this is a very important delivery mechanism. Then you go into the diagnostic side of it, right? Now, diagnostics also is divided into two different categories, which is, one is the in vitro diagnostics and other is the in vivo diagnostics, right? So in vitro, in vivo, what's the difference between that for the uninitiated? It is typically the people who come and draw your blood, right? They're called phlebotomists, who are actually coming and drawing your blood, right? And the things which is processed in that in a test tube or in a sample which is taken like a blood or any other sample, in diagnostics terms it's called histopathology. This is all part of the in vitro side, right? And then you have something called as in vivo, which is more to do with the radiology imaging. Now, why this difference? I'm calling it out upfront. Your solutions are going to be very, very different if you're working even within the diagnostic segment. If you're working for the in vitro diagnostic side of it, your solutions differ. And if you work for the radiology, it's very different. The clear classification is the high compute intensive solutions are which are going to be primarily more toward the radiology side of it, right? And then you have the pharmaceutical world, which is where we enter the life sciences side of it. Does pharmaceuticals complete the entire life sciences? The answer is no. But yeah, pharmaceutical companies are the most important element of the life sciences delivery mechanism. Although there's a lot of genomic companies, research, some of you may be building solutions on the genomics or other areas where there is a sect in the life sciences which focuses on the research, and then there is a sect of life sciences which focuses on the drug discovery and delivery and development, of course, right? So within pharma also there's a classification, which is one part of the pharma is called the generics, and other is called innovators. What are generics and innovators? I'll start with innovators. So you would have heard the organizations like Pfizer's and Moderna's of the world, folks who actually do a lot of research to find a drug for a particular disease or a particular ailment. They actually do a like a 10-year and this kind of a window for a research of a drug before they launch the market and they patent it. So those are the companies who are innovators. And then you have generics. Generics are the organizations who actually once the patent of a drug is about to expire, they actually take a license to manufacture the cheaper versions or cheaper alternatives around it, right? So if something like a crocin or a paracetamol or a Disprin is available to you for 10 rupees, 20, 30 rupees affordable, is because somebody has that generic manufacturing being done, right? So that is done. Otherwise, that was a very I would say elementary example. But even if you go towards high end drugs which are to treat with a cardiovascular disease or a diabetes management, right? They are also a lot of generic drugs which are there. Otherwise, the same drug would cost like 1,000 rupees a strip, which they are able to bring it down to 100 rupees a strip, right? So that's how the generics world happen in the pharma side, right? And one other very important element of the healthcare ecosystem is the medtech or the medical equipment side of it, right? Where you have all those large companies, Philips Healthcare, etc., who are building those massive machines around CT scans, etc., which are very, very tech, software, hardware included, right? So this is important for you to understand, upfront which area you want to build a solution, right? So one of the very important aspects that I firmly believe as a Googler and also otherwise is, especially in healthcare, I think we have to look at the problem which is actually which can have a very wide blast radius. What blast radius is meant here is which can have a very significant impact. For example, if you are building, let's say, for the sake of it, any solution are using AI which can solve for oncology and which can do a preventive, highly accurate diagnosis for somebody susceptible to a cancer or not. Now, this is a very, very high value, life saving intervention that some of your solution are doing, right? So very important before you get into the lot of the tech side of it, to actually get into the side where we are defining the problem. Now I see there certain questions are being put, but I think I'll take the last 10 minutes is what I'm going to keep it for the questions. But just a kind of a quick answer. I think Sisti has posted about what about mental health. Yes, absolutely. Mental health is actually a very, very essential and important part in terms of healthcare delivery. And in fact, some of the solutions I'm going to talk about, especially in the lines of how we are integrated with Fitbit with some of the mental health analytic organizations in terms of how they can bring in more valuable feedback and analytics to the user. So that's again there. Now the tech can solve for it, but it's very important to relate to the use case and the large scale impact. Now what's happening in the healthcare sector, right? Especially when it comes to the Indian segment. Since I think uh, uh, I believe that there's the audience today here, the folks who are out here, you'll be building a lot of the solutions for Bharat. So while there are a lot of global trends which are emerging, but if we come closer to home, these are the three challenges that we are actually solving for, right? How do we keep people well? How do we actually have the care continuum in place where the care is not like maybe a defined route, but it's more like a circular, it's more like a continuous feedback mechanism which is there, right? The third one is about accessibility and affordability. I think that's a very, very important aspect of it, right? Now how do we cover into these aspects is going to be very, very important part of how we divide and devise our solutions as well, right? Now, but if you look at, and if we were to deliver on all those three lines of action that we saw in the previous slide, right? So here I am actually making three audacious claims for healthcare in India. Okay. Now What are those claims? Healthcare still has a lot of negative connotation associated with it, right? It's like still we talk about it more like a sick care. How do we change that? And that is where a lot of the technology solutions are coming into picture in terms of how the preventive health is more about for keeping people away from the traditional healthcare, right? And that's the real value to the patients, right? Second thing is about how do we change that doctor first to diagnosis first. Right now it's India, if you look at from a WHO standards perspective, right, we have 1 is to 1500 roughly, if I remember the number correctly, for a doctor patient ratio, where there's an advice of 1 is to 1000. So we can't generate healthcare professionals overnight. The only way to ensure that the care reaches to the last person standing in the value chain is if we can help these doctors become more efficient with some of our solutions. And that's the kind of responsibility all of us who are there on this particular session is all about, right? How do we change that? Can Is there easy way of doing diagnosis? And as you know, point of care diagnosis, which is to the time where you don't need high tech equipment to do certain tests, is gaining a lot of momentum. Do you folks want to focus on that aspect? Does it The preventive health is an area which actually uh, is something you are passionate about? Because that's a real problem I feel that you folks can help solve in India, right? Third is also about the shift that needs to be brought in terms of where you are to where I am, right? It's still very lopsided towards that you have a problem, I need to go and find a hospital, I need to find a clinic, I won't need to find, right? How do you bring that entire ecosystem at home, to home, and that too, not to some select few or a particular strata, but a large variety, right? And that's where I think it's not only about tech, it's also about the affordable tech, which is very critical. Okay. Now, so what could be potential solutions, right? And now I think it would have become obvious. We focus on wellness care, get people, make sure that they are kind of out of this entire ecosystem. We make it like a connected care, always on. You have all those Fitbit, Apple Watch, everything what you wear. How do you do that? We do a lot of remote care, take a lot of the things, your monitoring, etc. Whatever it needs to be done becomes remote. But do take one food for thought. Do you folks think that can health tech solve all the healthcare challenges of healthcare uh, by working alone? Uh, and I'll take a pause here. If you want to think about it, that if you feel right that health tech does solve everything about healthcare, anyone wants to post anything on the chat, feel free to do that. If you feel that health tech alone can solve everything for healthcare, right? But even I think for the in the interest of time, what I've seen, at least in terms of the way uh, the entire landscape is evolving, I think healthcare is one of those industries or the one of those segments which is very domain and process intensive, right? So until you understand what is that workflow, until you understand what is the kind of stakeholders that the workflow is going to serve, it becomes very difficult and cumbersome to do just with tech, right? For example, we can keep building a lot of apps, but are we thinking about the medical professionals? We can't add that. Like I said, it doesn't happen overnight. So how can maybe a conversational AI or assistive AI solutions can help that cause, right? On one side, that there's a lot of push for the EHRs or the electronic health record system. I think that's a normal norm. If someone is has worked or has family friends in the US, right? EHR is just like, but in India, if you look at it, still a concept which is gaining traction now. At the same time, whether you talk about to a doctor in the US or you talk about a doctor in the NHS, you want to talk everywhere. I think one of the key problems the doctors will definitely highlight is we have to spend a lot of time in ingesting information, which is not their job essentially, right? Their job is to deliver care to the patient, that empathy that needs to come for the patient, right? It's not they don't want to do it, it is just that they are too uh, overburdened with these tasks, right? And especially from an Indian perspective, right? uh, that's a very unfortunate part, right? And beyond certain strata or beyond corporate houses who are ensuring their professionals, health insurance is still like a 10-20% kind of a penetration which is there, right? uh, why? It is also cost a lot of time, it is also access a lot of times, and sometimes it's a mix of both, right? So how can cheaper solutions actually emerge? How can those bite-sized insurance solutions can actually offer? And by the way, this is tech can just enable a part of it, but there's a lot of thinking has to go beyond that. That is the reason I'm encouraging again and again to go back and tie it up with a larger use case, and then bring it back with tech, right? Your impact and the blast radius suddenly increases drastically. Other thing is that although the government of the day has been focusing a lot in terms of reducing the burden on the common man, but it's also a responsibility of the entire ecosystem, like the private sector also coming, a lot of the technology firms also coming together, and we do a lot of work in terms of something like, I think you would have heard about open health stack, things like that. So all of us have to contribute toward that line where the ecosystem becomes more accessible, and when it becomes accessible, it should also become cheaper in that regard. uh, Now, this is the kind of question that I want to leave it to you all, right? That if you look at it, is this is by now you would have realized there's a lot of moving parts which are working, right? Where if you were to enable, if you were to look at the heart of this entire ecosystem, which is the doctor patient, there are a lot of stakeholders, lot of moving parts, lot of enablement that has to happen around that, right? And even if your solution is targeting any small aspect of it, trust me that the healthcare is a subject, it is not relevant, it's not like a credit card audience, it's not like a particular retail audience, right? It's actually applicable to all. So whatever you are going to do is going to have a very huge impact. So in this complex ecosystem, simplify, look at the target use case, and see that how do you want to solve for that backward with tech, right? uh, Now, some of you, if you have been working on healthcare solutions for the Indian segment or for any other segment, maybe if you're trying, you have done some sandboxes. I think these terms would not be new for you. But for the others who have not, I think these are the 10 sort of 10 commandments, I would say, for survival basics to understand, right? You have something called as the fast health interoperability resources, fire, which is uh, 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 it's, I would not say that it's only that a standard like fire becomes a mandate in the country, then it's to be adopted. Because under the hoods it still has, if you look at fire, it still has the JSON dialect, right? It is about building that interoperability into the ecosystem. While in developed countries like US, it's a matter of time that it's going to just become a mandate. In India, it may take time for fire or maybe any other open data interoperability standard will become a mandate. But in healthcare, this has been a big problem to have an interoperable mechanism where there's a lot of innovation can happen with data sharing in a compliant manner, in a secure manner, right? Which is again, there's a lot of the equation that has been solved by Google Cloud, right? HIPAA compliances, HL7V2 is the messages that is transmitted by EHRs who are complying with that, which is sort of a kind of a standard approach to help it either convert it into fire format and then do more interoperability around it. But that's the area where the focus is being there to at least standardize it. EHR and EMRs, I'm sure you would have heard about it. The electronic health record system, Cerner's Epic, not very popular in India right now. But there's a lot of bespoke work that happens. There are small packages that are there. A lot of the hospital chains, they also build their own packages around it. So that adds again a complexity to the problem. That again, how do you bring it to a data format which is interoperable and can be shared, right? And then it's about, if you are interested into the side of the diagnostics, then DICOM and PACS are something that you have to understand in more greater depth, because these are, when DICOM is that data exchange mechanism for the radiology and the imaging side of the tech. So that's important. And plus then also, if you look at ICD 1011 codes, which is the International Classification of Diseases, excuse me, and which is essentially to say that everything, whether it's a symptom, a disease, or a procedure, everything has a code associated with it, and there's some 85,000 different codes which are standardized, right? What is the value of the standardization? If this everything is tied up with a code, which is predefined, it actually makes the downstream processing or analytics of the same thing very easy, right? So that is what we are trying to do. And some of the solutions, like in Google Cloud, which is like in healthcare NLP AI, we have tried to standardize a lot of this thing inbuilt into the in the solution, right? And of course, there's a lot of focus which is being now seen into the longitudinal health or patient record. For the uninitiated, it's about uh, creating a continuous record of your treatment, or everything which has to do with in terms of, let's say a person X, or let's say Manish in this case, went to a hospital X, right? And for any reasons, if he has to go to an hospital Y, there should be continuity of that record, right? And that can only happen first if it is interoperable, and there are mechanisms which are there, to share that data. If you look at, and lot of you, I'm sure, if you're working on the healthcare ideas, you would have come across the Ayushman Bharat digital mission. And if you do read the finer print around the UHI, or the Unified Health Interface, you will understand that is the attempt by the country to help in making it interoperable, right? So to create that longitudinal patient record, to create that longitudinal health record, which is actually the value to the patient in this particular ecosystem, right? So this is important if you're working on the solutions around it, right? Now let me now come to some of the things in which Google Cloud is being doing new, right? And that's where I want to start on the cloud piece, which is what we are doing. Some of the things that you may have heard in the news for solutions, but recently we have actually launched something around called as a device connect, which is more about bringing the data from the variables on a common platform through Google Cloud, where a lot of analytics can be actually done, right? And this is actually targeting the same kind of problem that I explained so far, right? We don't have a longitudinal view of the patient. Why can't a device with a consent, if let's say I am wearing a Fitbit or any kind of watch, doesn't matter which brand, right? If there's a common standard and framework which is there, and if I provide the consent, why can't it go from my diagnosis? Why can't it be part of my diagnosis? Lot of the protocols which are there, of course, until it becomes a clinical grade, it can't be the primary aspect of doing a diagnosis, but it definitely is very useful as some of the information to a clinician to understand what's happening with you. Could be your sleep patterns, could be your SpO2, could be your very simple ECG which is being captured, right? Could be your something we called as CGM in the world of the diabetes, which is the continuous glucose monitoring, right? So Fitbit is even working on partnering with some of the organization like Abbott to bring that thing also part of the equation to do that, right? So, but in essence, if you have the device cloud, right, you are actually creating that huge amount of data which is like even not even considered for analysis from a health perspective into the mainstream, and that is the challenge it is actually addressing, right? So what does it does, right? It's helping in simplifying the patient consent. Like I said, I'll keep harping on this point. It's not that innovation is very complex in healthcare as compared to a banking, as compared to a retail, or as compared to other things, because it's very complex because just because of the data. But the innovation in healthcare is also very complex because it is governed by a lot more standards, like from as compared to other industry. For example, if you're doing something, and especially let's say you're building a solution which is targeting US segment, right? You can't do anything without HIPAA and HITES CSF, right? So this is very very critical for you to understand that the innovation has to happen, but the guardrails are these regulations and regulatory framework. And again, how do you increase the insight for the patient? And then if you look at it, all these four areas, right, now there's a single solution which is helping you solve more problems, right? For example, in one of the hospital chains we are working in India, we are helping them solve a pre-post surgery kind of a problem, where they what they are actually essentially is doing is in their orthopedic department, right? And you can check on YouTube, there's a beautiful video around it on the workflow. It's like uh, the typical problem that happens is when somebody goes, somebody, let's say, go wants to go for a knee replacement surgery or something around that, right? The problem that happens is, there are, for doing that surgery, before that there needs to be some parameters that need to be controlled, right? And then post surgery also, the same parameters need to be monitored. Now what happens is, typically the patient will come, the doctor will do some test, and the things will come out that the parameters are not controlled. It gives a lot of pain to the patient who's already in pain, or who was already in pain, right? And on the other side, the hospital chains have, like, if they feel that beyond 3 days it is not optimum for a patient to stay even in the hospital, right? Because it's no brainer that somebody can recover faster at home than being in the environment of the hospital, right? So how do they do that? Because if they send somebody faster, they'll not be able to monitor that. So there has to be a way they can do remote monitoring. So that is what something like, one of the examples I wanted to quote, how something like a Fitbit with an analytical platform can solve for it. Now this, lot of these things, can you folks can also think that, what can be more to be done with variables, and build solutions using your ideas. uh, Other thing which is very important is, I touched upon the aspects in the imaging side of it, right? The medical imaging is another very, very important element. Now, if you do, there's a research which was done, which was showed that 80% of the healthcare data is unstructured, right? Typically when we talk about very, I mean, the ones which goes is that there could be data which is ingested into their hospital, patient information, everything. But 80% of the data, a lot of that data which is not even in that tabular or the structured format which is habitual of being used, right? So how do you target that, right? And that's where this interoperability doesn't only apply to a data which needs to be structured on brought into structured format, but it's also about how do you bring the imaging into also mainstream analysis, right? Finally, I think the idea is to bring everything on the table, on the clinicians in front of the clinician, so that he or she can make a very informed decision, rather than searching like for one piece of the other. Why can't, with the prescription, a variable and then imaging data can be put in the one place? And that is, in true sense, you're building that interoperability, and in a true sense you are helping the clinician reduce the time, right, of the diagnosis which is there. And that is where, it's, if there's a solution that we have worked, and it's again launched, you can study about it. It's called Medical Imaging AI Suite, where there is a focus around how do you simplify the analysis in terms of the medical imaging, um, and enable interoperability. How do you put AI on the top of it, on the medical imaging, millions of images, which is the data is there, and can reduce the burden on a radiologist to make the decisions faster, right? And some of these have, mind you, have so well trained models which are giving as high accuracy as a seasoned radiologist gonna give. Is the approach that a seasoned radiologist is gonna go? The answer is no. What is the solution? What they see, the HITL piece, the human in the loop, as we say, is not gonna go in healthcare. I don't see it's gonna go. I'll I will not even exaggerate if I'll say ever, right? Because finally you're dealing with people's lives here. It's not that you lose some money, you do. It's any small miscalculation by a tool can lead to somebody's life, right? So they will be human in the loop. What you want to do, or I want to do here as the health tech or healthcare professional, is to reduce that burden on the clinician and increase the accuracy of these models so that they can make a better decision. Simple example is, if anybody, a layman, will say a brain hemorrhage happens, right? A brain hemorrhage, if you look at it, it is a very complex ecosystem in itself, right? There's a particular kind of lesions which are seen. There's a particular lesions which are seen where the progression is faster versus progression is minor. Something can lead to tumorous, something will not lead to tumorous. There are a lot of ifs and buts. But imagine the tool doing that job, and finally a radiologist is just looking at it, either validating or rejecting the hypothesis. That is where something like some of these solutions are able to do, right? uh, Now here, uh, you have multiple components. If you want to innovate on certain areas, something like if I were to slice and dice a medical imaging AI, right, you can improve a storage tech which is around making it easier, a more accurate way of doing or optimizing the storage. You can improve the AI around it, right? It's also about how do you have better imaging AI pipelines which can help. So there are lot of elements that can be actually used to improve the solutions, right? So there is a platform which becomes available to you, but how do you further build on that, make it more specific? Let's say if today the platform is built on training a larger data set on oncology, how can you go very very specific to, let's say, all good as from an oncology to neurodegenerative disorders, right? So that's a progression when you see a platform at a horizontal level, and then you are actually going very very specific to certain disease problems and patterns to solve for it. And by the way, any such solution, like I said when I started the conversation, will have a huge ramifications and impact. Okay. Now one of the things that I mentioned is that, large part of it, right? And it's especially if I were to call a developed country which has more developed healthcare ecosystem, like anything in the west or any other country, versus what we are trying to do, we are in that journey. But right now the bigger problem, if you talk to lot of the folks in the private sector or even in the other areas, is how do you get that unstructured data into insights and keep it either converted into a semi-structured kind of a format or a structured format for usage. Simple classic example is doctor prescriptions. I think all of us know that it's more like a Greek and Latin to people like you and me. I mean, this can only be recognized by a chemist or the doctor himself or herself, right? But how do you make it legible for an OCR, an optical character recognition, to read through that, right? So that is something we are doing. Our research team, Google Research India team, is doing. Is there's a solution called Doc Lens, on which they are actually helping parse the prescription, the handwritten information, right? And it's about increasing more and more accuracy. As a lot of folks like you can actually come in and actually make the juggernaut even more powerful in saying that how do we increase the accuracy of the models, right? Because these accuracy is still a very big challenge, right? Although we are achieving a good accuracy, it's a tune of 58 to 60% somewhere that I know, if I remember correctly. But beyond industry standard, but that's huge for a handwritten OCR. You're not talking about a printed or a format which is very easy to be read and then parsing the information. So that's where I think the focus of some solution like a healthcare NLP NLP AI. And if let's say I don't know if I'll be able to do a demo. I had a demo to show what we did on the healthcare NLP AI. But I think what this demo is also actually talking about is, if you see what you see on your screen, right? Typically, this is how a discharge summary will look like. Okay. Now, when you see this discharge summary, it has a mix of a simple English, plain English, healthcare data, which is, and healthcare data, by the way, is in multiple forms. One form is more about a medication being talked about, something it could be a medical condition being talked about. Other could be as good as somebody talking about a symptom, right? Or other thing is about, it could be talked about the patient family history, or something happening in the past or something happening now, which in the medical parlance we call it a temporal assessment, right? Now there, you understand there are a lot of moving part which is happening on a simple discharge summary itself. So just to give you an understanding on the kind of complexity that you deal with, right, on the unstructured data in the healthcare. Now this is what we have solved with something within healthcare NLP AI. What it basically does is it is actually trained on all the medical data at the back end, right? And then it can have that semantic layer, it has that semantic layer inbuilt into it, where it can sift through that data, the data which is in verbios, and then can find out what are the healthcare terms into it, and it can map it to all the ICD 1011, Loyency, SNOMED city, other standards code that I talked about. So at a stage one, it can actually parse that information. What it does at a stage two, it can actually say which are the entities are talked about here. Where are you talking about a symptom? Where are you talking about a medication? Where are you talking about a procedure? Let's say, for example, somebody is talking about a biopsy. That's a procedure. Somebody is talking about metformin. That's a medicine that the type 2 diabetes patients actually take. Something is talking about fever chills, and these are the symptoms, right? So it helps you classify that, and then also creates a contextual map around it, right? what is the context on which is spoken, what is the temporal assessment. Is it like I can say I was a smoker and now I'm feeling a breathlessness? So there was and now, right? So this solution helps in actually segregating that. Is it, and with a certain level of confidence score with AI, that what is the confidence of that outcome which is there for a clinician to just review, and the same data can be used for a clinician to build a prescription faster. So this is the kind of solution which actually helps, because finally when you have such kind of solution, the physician or a clinician has more time with you as a patient, right? And this is where your real value comes, right? Because what happens, you imagine yourself, right? Let's say if I'm a doctor and if you come to me and you are telling me your symptoms or problems, I'm just typing in something on my screen, how would you feel about it, right? One is you're going through a pain. Second thing is you feel that Manish is even not looking at me. Is he even understanding my problem? Whereas poor Manish, as a clinician, Dr. Manish is just trying to do his job, right? So that's where I think if you build some of the solutions and which can be further integrated with something like a recommendations AI, you are making the doctor's life easier. At the end, you are making his or her experience giving to the patient more, right? So you are, with the tech, that is the real way you are actually making this entire ecosystem better, right? One of the hospital chains what we are working is something, when you look at something called as a symptom checker, which is more like a conversational AI kind of a tool, which helps in triaging the problem, right? From a medical parlance, the triaging the problem is about that. if i if I shared three or four areas, like I said that I am conversing with you on the board, I say I have fever, I have nausea, I have let's say some other problem, or maybe I had blood in my sputum. Let's say that these are three things, right? Now the intelligence of the tool comes into it when it triages it and says, okay, you had this problem, what is the duration, did it happen earlier, any other condition you have. It will have those questions, and based on that it could actually either lead to a particular diagnostics test which can be done with as per the regulations, allowed or not, based on what it has been done. Or let's say someone says they add another thing, they said I had a chemotherapy a week back. Now suddenly your triaging changes, right? Now if someone had without a chemo, a normal person having some of those symptoms may not be that serious, versus somebody who had a chemo, it could be life threatening. So immediately the bot can actually transfer that to a doctor, right? Which is an urgency. It is triaging itself. So it's actually making that entire workflow easier, for the doctor. And by the time the doctor sees the patient, he or she already has some of the information in the structured format. So that's where I think some of these solutions focus. This is more like, I just wanted to give you a view, like if you were to build knowledge graphs, how does the world actually looks like, right? If you're building those knowledge graphs, there it's more about how do you connect different dots, right? It's something Google has been doing on the search, right? Which we are also looking at, how do we do the same in, let's say, very specific to healthcare. So it's about, you take multiple sources and kind of create a tree of that, and create an information matrix sort of at the back end using AI. If let's say that if there was a CAD is coronary artery disease, which is very commonly your heart related ailment, you would have also heard, right? And then it says that there's a patient. One of the key challenges is, it could be that there's a patient who needs a new drug for a particular condition, and that patient is not getting it because it's not even connected to that ecosystem. Hello? Yeah, I think I lost the connection for a moment, but I think I should be back now. So it's essentially, it's what I was trying to tell you folks is, there could be a patient who could be treated by multiple doctors, and that patient could also be a potential recipient of a new drug which is in advanced stages of trial. Could be a very terminally ill patient. Now today we don't have a right mechanism, and that is where I was harping upon the interoperability of the ecosystem, that if the data sources are not connected, there could be a patient who is the right recipient of an advanced trial drug, right? But he or she is not getting it because it's not even connected to that ecosystem. In this slide, this is the right, you can say, a textbook definition of how healthcare and life sciences can be integrated on a single threshold, right? In the healthcare parlance, we say bedside to bench side, right? Which is essentially from research to actually delivering the care to the patient. Now a power of a knowledge graph is can a tech like that can solve for that. So maybe you folks want to explore and work around, if you want to work or see that if knowledge graphs can actually is your calling, and you want to build knowledge graphs around solving for this particular problem. uh, I think cloud healthcare API is one of the product and solution which is very very common, commonly used in from our healthcare perspective. Uh, so this is where we are doing that interoperability in action. So what healthcare API does is it's you have a Fire API, a DICOM API, a Consent API, and HL72 API. All these are targeting to take a lot of the data and inbuilt, the with the regulatory framework inbuilt into these APIs, transfer and change the data to the format, right? To the format in a way the systems can consume. That's what the fire is all about. And this is where some of the solutions overall, when you talk about interoperability and AI. Now, interoperability and AI, in a way, you can say is at the heart of how Google Cloud is building the solution piece, right? It's essentially to say that how can we ensure that there are solutions which can bring data to a common format can be used. Second thing, how can that be layered up with AI to actually run cutting edge analytics, right? So as a stage one, you have a primary use case. What is the primary use case? To make the data interoperable, which can be used, for example, a large hospital chain who is sitting, let's say, 60 million of the patient record. If they make the data interoperable, if they have a way of at a scale where they can de-identify their data and share it for the research purposes, that is the right way to do it. And that's what something like an healthcare API, there's a de-identification API as part of healthcare API suite, which is doing that. So you may want to explore and see the power of it and build more solutions around it, right? More AI solutions around it, where you're using some of the the data in a compliant manner, running more kind of analytics in the data, using platforms like Vertex AI, which is in Google's cloud parlance we call AI of AI, trained on thousands of different kind of models which can actually look at the data and say that how you want to actually build AI on top of it, right? So the message that I wanted to give is there's lot of options available, especially when I look at from a healthcare and life sciences perspective for developers to build solutions around it, right? And cloud healthcare API is one very important element of it. Cloud healthcare NLP AI is another very important element of it. you know while cloud healthcare API largely targets the structured data side of the problem, cloud NLP API or AI targets the unstructured side of the problem, right? If you combine both, they actually are solving the large part of the problem, right? So how do you actually use and make it in mainstream is something that I would encourage to do. Now this is how, so far, whatever I have explained it to you, see, this is a classic way of saying that how all of that can come together. If, let's say, hypothetically, although the world is not ideal, but let's say hypothetically we have institutions, we have startups, we have government, private sector partnering, right? Excuse me. So there you can have an architecture like that, right, where you have structured data which can be shared on the formats that I just shared, unstructured data, and then device data, what I showed in Fitbit, right? So all the three things what I showed it to you, right? How can that they work in tandem? So it is possible today on Google Cloud, where you can take all these different kind of input data sources. There's a harmonization which is possible with cloud healthcare API. There are other solutions which actually work in tandem, all the way you take it to AI with Vertex AI kind of solutions, right? So you have a large playground from left to right to actually kind of build solutions. While this is more like an architecture which targets a lot of areas, you can actually pick and choose to solve for a problem. For example, you can actually use the auto ML healthcare models to maybe create a very classic model of neurodegenerative disorders. It could be as simple as that you are isolating a problem and working on it, right? But again, it's very important to actually look at which are the right components which can help you build those solution for you, right? uh, just remember this is not like a, I would not say this is like a uh, every hospital or everybody will follow that, but it is a classic way of looking at how the data exchange typically happens, right? So there's hospital, there's a clinic, right? When you look at an if let's say the provider has an electronic health record, they can share the structured information into the from an HL7V2 kind of a format. The radiology data can be shared on the DICOM format, right? And then further there could be a further analysis which can be done using the capabilities that I just talked about to actually use data from a for a primary use case for to treat that patient, and then archiving that data in their native in its native format or a analyzed format for further processing for analytical and research use cases. So that is a kind of a workflow which is you can think about while building solutions, right? A bit busy slide, but this is what one of our key uh, uh, solutions, or I would say this is more like a platform called Healthcare Data Engine. I don't want to get into detail of everything, but understand this is the detailing of, if let's say if I were to build a solution from scratch, let's say I was a startup and I wanted to build a solution from scratch for taking different data from all different kind of EHRs or other sources, and then take it all the way to process the data for a primary use case, which is to build a longitudinal patient record. The definition I talked about earlier in my presentation, that how the data gets appended, right? Every time you go, you don't have to narrate the same story. Rather, there's a history being built credibly, which is immutable in sense because the consent framework is also managing, the provenance is being managed. This is a solution which actually does that, right? And if you look at it is this is a lot of interesting things from Google Cloud is being used, right? You're using data flow, you are using BigQuery, you are using the healthcare API into it, right? And all of that is coming together to solve for a problem, right? And the problem is to actually build longitudinal patient record. What I also want to draw your attention, if you go to the rightmost side, right, that is where the interesting USP which comes on a solution like this, and where Google's cutting edge focus on healthcare and life sciences can be seen, is that you not only you use this data for a particular building it into structure, but you can actually flatten this data also, bring it to BigQuery, and process it for an analytical and secondary use case, right? Which is one of a very complex thing that you have brought into the data into fire. But what about if you want to use the same data for analytics straight away? Can it be made available straight away in a SQL like dialect, right? So this can be done possible with a healthcare data engine kind of architecture. So the messaging is like, while this is a platform with this is more like an integrated ecosystem, but there are a lot of components which are available on Google Cloud for you to try, and try that. And if let's say want to build something around medical imaging AI, which is very compute intensive, you have that kind of a power which is available. You want to create something like what you're seeing on the screen for a longitudinal patient record, you can also think about. By the way, this solution is more focused on the US side of it. Maybe some of you would want to build on Google Cloud, which is more relevant from an Indian perspective. So would encourage that, look at those areas, like I said, EHR adoption, forget about interoperability. EHR adoption, simple EHR solutions is still a big challenge. You may want to work on those areas which can help solve for the country. uh, so while it's I'm sharing on the lighter note, but yes, people, healthcare professionals, a lot of you who are going to become healthcare professionals in the future, you will face this a challenge, because uh, on one side this looks very obvious things, that there's data lying, why are we not using it for common good, common cause, right? It should be very easy. It should be, why can't we just make all data standards very common? I think it's easier said than done. US has been trying to solve this problem for last 40 years. They're still in that journey. They have not solved it. I think as a country, India is doing much better. I would say, so we are in a much better situation. But the key is, how do we make those building blocks, right? Which are very specific for Bharat, and that's where the frugal innovation is the word that I typically use, right? It's not purely the innovation piece, but the frugal one. How do you build those solutions which are cost effective, which can be adopted? Because for a country like ours, until and unless something is cost effective, no matter how fantastic is the solution, it's not going to see the light of the day. So I would encourage to think about that. Think about the problem that you want to solve. Think about what you want to do, in a way to build certain solutions which can be scaled, which can be adopted faster, and which can actually help the larger good, right? So with that message, I will probably take a pause and would say that if there are certain questions, I can answer if we have another 5-7 minutes.
Hi,
Hi.
Manish.
Hi, Manish.
Yeah, yeah. So I think it was a great session indeed. So, is there anything you would like to tell your audience, or for wrapping up this? Is there anything you would like to add? Something?
Yeah, the only thing that I would like to add here is that, uh, for the audience here is, look at some of the areas which are, I mean, relatively untouched from an Indian perspective on the healthcare. And by untouched, I mean solving for a lot of the secondary diseases, like, maybe oncology, coronary artery disease. India as a country is becoming the hub for non-communicable diseases. That itself is a huge problem statement for me. Can you
Yeah.
build solutions? I would urge you to build solutions which can help people stay well. Like I said when I started my conversation, shift your focus from, uh, helping people just manage their diseases. I think the focus needs to shift now. How do you ensure that people they don't land up to diseases itself? And if they land up to the diseases, this is too late in their lifespan. I think these are the two things I would urge all of you to work on, the solution, which I call as a wellness management.
Okay. So, okay, it's time to wrap up this conversation with you, Manish. Thank you so much for your time. Thank you so much for being with us today. Yeah. Thank you
Thank
so much,
you.
Manish.
Thank
Yeah, bye
you. It
bye.
was a pleasure. I wish everybody all the best.
Thank you. So, guys, with us we have Silpesh Shah as well. So he'll be joining. So let me add him as well. Hey, hi, Shilpesh. How are you?
Hi, Mishika. I'm good.
Yeah,
Thank you. Hello, everyone.
yeah, yeah. So over to you, Shilpesh.
For this session, let me present my slides. I hope you can see my slides. Okay.
Yes,
So,
Shilpesh. Yeah.
yeah. So I'll be talking about some of the AMD Epic CPU benefits from healthcare perspective. So as AMD Epic is a CPU which has got a lot of scalability, a lot of performance, and it delivers everything by consuming less amount of power. And it has, from security perspective, very cutting edge technologies in terms of confidential computing that can be enabled on Google Cloud. So Google Cloud uses those technologies, and you can use those things to protect your data. So let's dig deep into it. You can achieve a lot of TCO savings, as Manish mentioned. You need to deploy a lot of services. Whether it is monolithic kind of architecture, or you are using Kubernetes based containerized application development environment, or some of for some of the requirements you might be using built-in Google services. So when you are developing your applications, you can deploy those things whenever you require any instance or any Kubernetes platform GKE. You can deploy those things on AMD instances, and the benefits are, there is a lot of TCO savings from Google pricing perspective compared to competition, as well as there is improvement in performance, and everything is efficient. That means it consumes less amount of power. So a lot of corporates, a lot of customers have these greenhouse gas emission reduction targets, sustainability targets. So AMD instances really help into that. And AMD is x86 CPU, so everything is compatible. You can deploy everything with confidence. And the security features, which I will talk about, which are cutting edge kind of features on the CPU part. So we have three different instances available on Google Cloud based on AMD EPYC CPUs. So whenever you deploy for your project any of the VMs, make sure that you use one of these three VMs, on AMD EPYC CPUs, so that you can get all those benefits. So first one is N2D, which is general purpose VM. It is available on Google Cloud on AMD's second and third generation EPYC processors. So you will see a lot of Google documentation. The second generation name is Rome, and the third generation is Milan. So that's the AMD EPYC generations. I request you to consume Milan-based AMD EPYC CPUs, because that is the third generation, which is the latest, and it also provides at least 30% price performance improvement over the previous generation. Then second one is compute optimized C2D based instances, and then we have for scalable kind of infrastructure, you can deploy T2D kind of instances. So let's dig deep into the AMD security features. So what AMD has done is that when industry is looking at data security, there is security solution already available for data at rest, which is when the data is stored on a storage or any hard disk drive, in terms of encryption of that storage device. And when you are sending the data over the network, again you can encrypt the data. So both these solutions are available on Google, as well as it is available industry wide, but no one has a solution till AMD came out with, and along with Google, in terms of confidential computing, which is basically when the data is in use. So data in use means when the data is sitting or it is being accessed through memory. When the data is in the memory, it is in plain text format. So that's where a hacker can hack into and read the data. So that's how AMD actually encrypts. So this is how it is done. AMD has 128-bit encryption engine in the CPU itself, and we can encrypt the data for your respective virtual machines. There is a separate encryption key. So if there are two different VMs deployed, both the VMs will have a different encryption key through which its memory, that virtual machine's memory, will be encrypted, and that's how that entire segregation is done. So that is how AMD helps in securing the data. When the data is in use, it is secured, uh, and basically it is very easy. So you can I have a slide on that. Yeah. So I will go to that. So you can actually, this is the Google Cloud interface where you can just click on enable, and that confidential computing feature gets enabled on Google Cloud. So that's how Google has made it so easy, working along with AMD, and from interface perspective, there is no complexity. It's just that when you are creating a VM, you can enable this confidential VM service. Also, when you deploy confidential computing, which is encrypting the memory, there are there could be some concerns like will it reduce my application's performance. So Yellow Dog, which is a customer of ours, they have executed this test, and they found that there is no difference when the VM is uh, without confidential computing and when it is running with confidential computing. So you can be rest assured that there is no performance impact, and you can utilize this feature very well. So there is this website which we have built along with for Google Cloud AMD solutions, which is known as buildboldcloud.com. It's shown here, and this has got a lot of case studies on the home screen itself. You can scroll down, and you will come to these use cases where you can find these healthcare use case. You can refer to this product brief. It talks about all these things what I spoke about, and this actually helps protect the data, because in healthcare there is also a lot of research which happens, and sometimes those research happens at a very high cost, and that data needs to be protected, because if someone steals that, they can get that kind of advantage. So this confidential computing really helps from that perspective. Also, a lot of governments have these regulations, and on healthcare data cannot be stolen. So there are regulations around that, and the confidential computing deployment really helps to protect the data from that perspective also. So apart from the security thing, AMD CPUs also help in terms of performance. When the doctor is accessing some data, or when the doctor is say using your app, and if the app takes a lot of time to come out with what with the data that the doctor is requesting or the user is requesting, it will really impact the user sentiment, and your it will affect the usage of the applications. Like no one has got time today, and everybody wants, as soon as I click on something, I want the results faster. So AMD Epic CPUs have a lot of performance in terms of the architecture, etc., as well as we have a lot of bandwidth. So it's very balanced architecture. It integrates well, whether the requirement is for transaction or analytics, or any other requirements from the application perspective. So you can use AMD Epic based instances uh, in any kind of application requirements, and those instances will deliver the performance that is requested by your application. So you can be rest assured on that, and you can use the AMD Epic based instances quite confidently. So that's about it from my side. Thank you very much.
Thank you so much, Silpesh, for this amazing session. Thank you so much for being with us today. Thank
Thank you.
you. Yeah. Thank you so much, everyone, for joining with us today. We'll meet again with another workshop. Till then, do follow us on our social media channel and stay tuned. Bye bye.